GL Datta to please address the gathering. Sir, please, we can take over from now.
Okay, thank you very much. At the outset, I would like to thank on my own behalf and on behalf of IIW Kolkata branch, the authorities of Sri Global University, in particular, its great leader and president, Sri Sandeep Kumar Rao, for starting the students chapter of IIW-India in this university. It's indeed a very right decision, and I hope time will prove its worth. On behalf of my branch, I also welcome everybody present in this inaugural function and congratulate the students for joining the Welding fraternity. Next. Next. Welding was considered largely a skill till about the middle of the last century, when people started realizing the importance of science in welding. India had a chapter of the Welding Institute, London. A few very dynamic and foresighted members of this Indian chapter could visualize what was in store for welding, for industrialization and nation building in India in the near future. So they came together and formed the Indian Institute of Welding on 22nd April 1966 to foster development of welding science and engineering in welding. Next. This is our headquarters of IIW-India. It's located in Calcutta on the Eastern Metropolitan Bypass. And in one floor, some space is there for the Kolkata branch. Next. IIW-India has now 13 branches all over the country and 2 centers, including one at Bhubaneswar. The territory of Kolkata branch includes West Bengal, Odisha, and states in the northeast. Next. The mission of our institute is to promote education and training, qualification and certification in line with international standards. With the push of industrialization and nation building after we achieved independence, it was found that there was huge shortage of qualified and trained manpower in welding. And IIW India stepped in to find solution to this problem. IIW India now is recognized internationally. We are a member of the International Institute of Welding, which has about 57 other countries as members. Ours is a member of ASEAN Welding Federation. Confederation of Indian Industry is also one where we are a member. We are a member of Quality Council of India. We are also a member of the board of directors of the Indian Iron Steel Skills Sector. We have participated in our Cup International competition. Next. We have several objectives. The major ones include human resource development in welding, technology diffusion, R&D in welding, and promoting health and safety. Next. Our primary activities include conducting technical meetings, workshops, industry-oriented training programs, organizing seminars, conferences, and exhibitions at transnational as well as international levels. We publish a journal called Indian Welding Journal in collaboration with the American Welding Society. We are conducting an examination called IIW to qualify them to be associate member of an institute. We organize various welding skill competitions. Next. Talking on welding is indeed a very multidisciplinary field of activity today. It comprises of all fields of engineering and science that you can name, like metallurgy and materials engineering, mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, instrument system engineering, computer science and engineering, IT, chemical engineering, and if anything else is left, it is included as a part of our activity. And in welding science and technology largely depends on the sciences like physics, chemistry, math. Even medical science has something to contribute for the development of welding. Activities include development of welding processes, machines, equipment, automation, real-time monitoring, metallurgical analysis, health and safety, and so on. Next. We encourage our students to join IIW-India student members and form student chapters in their institutions. Subsequently, they join this profession as welding engineer, welding technologist, welding quality inspector, designer for welded joints, marketing engineer, automation engineer, and so on and so forth. Next. Activities of the student chapter are many, including conducting technical talks, seminars, workshops, paper presentations, quizzes, industry visits, attending seminars, workshops, conferences organized by IIW-India in India and at international level. Even international level competitions and conferences are also part of their activity. Organizing competitions is one important activity of this student chapter. This slide shows an event being organized jointly in the month of October by IIW-India Kolkata branch and Colony Government Engineering. It's a competition on technical paper contest, presentation, and contest by students. And the students of the Raman University student chapter are most welcome to participate in this event. Next. This slide shows a view of Oil India exhibition organized at Calcutta, where students participated to gain knowledge on the latest trends in welding technology. Let me tell you, in such exhibitions, not only the the latest industries bring their products, but also some of the foreign countries participate in sustainability. As I said earlier, there is a huge shortage of trained manpower in welding, and IIW-India has taken several initiatives to bridge the gap. Next. Next. In India, under IIW-India is imparting international qualifications. IIW-India is collaborating with Sector Skills Council of India, as I said earlier, for welfare certification schemes. We conduct them IIW examination and many more. Next. The international qualifications which our ANB India is promoting, conducting, certifying include international welding engineer, international welding technologist, international welding specialist, international welding practitioner, international welding inspection personnel, international welder. Next. Other activities include other activities of India include our activity through NBCC, where the manufacturer certification is done. We have several activities done in the past and future. We have in pipeline for technology diffusion. We have been training not only the welding personnel, but also the trainers. We have been conducting national level skill competition. National level skill competitions include best welding engineer competition, aspirant welding engineer competition, best welder competition for women, and we nominate participants for Asian Cup competition. We have a very good track record of winning prizes in art cup competition held in China in 2017, 18, and 19. Next. Next. This is a photograph of the best welding engineer 2019 competition, and the prizes are being given. Next one. This is again a photograph of the aspirant welding engineer 2019 competition. We are very proud to say that the runner was from the C.P. Raman Global University. Congratulations and thanks. Next one. The winner in the best welder competition 2019 was again from the C.V. Raman Global University. Next one. Best welder competition for women in 2019 was held again in this university, and these are the two photographs showing some parts of the participants. I mean, some participants. Yes. Next. We participated in art cup competition 2019 and one also held in China, and we are again very proud to say that we got silver and bronze medals. Next one. Welding is used for joining, fabrication, repair, and maintenance of defective, worn-out components. It is used for hard facing, for surfacing, and for improving the life of the components. And welding finds a large application area. Next one. To understand the volume of welding activity, steel consumption per capita steel consumption or the steel consumption for a particular nation is an indicator. Roughly, 4 kg of weld metal is deposited for every ton of steel that goes in the infrastructure building and other activities in a country. Our steel consumption exceeded 110 million tons in 2019, and it is projected to go up to 300 million tons in the next 10 years. So one can expect the volume of welding activity that is to go up, and the need for the trained welding personnel at all levels, how it is going to be there. Next. Welding as a profession opens up many opportunities, and this slide shows various aspects of the career, like nature of job, technical content, career growth, pay packages, and so on and so forth. Due to shortage of time, I will refrain myself from presenting these data. Next one. Uh, After passing through three three industrial revolutions in the past, we are now in the fourth revolution, or we say Industry 4.0. Now we talk about Internet of Things, cloud computing, real-time monitoring, automation, remote control, and so on and so forth. These are all part of welding activity today. Next. The global trend of education is what we call today outcome-based education. Key features of outcome-based education lie in collaboration of the educational institutions on the one hand, and industry and professional societies on the other hand, for various purposes, with the aim to make education need-based. This is suitably factored in accreditation by NBA, NAC, and even NIRF ranking. Students become more employable. So we welcome C.V. Raman Global University to join hands with IIW India to take the education forward. Next. IIW India Kolkata branch desires to collaborate with C.V. Raman Global University. We can provide live projects to students, and our experts can collaborate with faculty of your university in making the projects lively and fruitful. Next. It had been a great talking to a select group of students and faculty of C.V. Raman Global University. I am really fortunate, grateful to the C.V. Raman Global University. I wish all the best to all of you. Thank you very much.
Thank you, sir. Thank you very much for such an informative presentation. A brief of various aspects of welding of IIW, how it benefits the students. Definitely, it would have been a motivating thing for all the students present here. Thank you very much, sir. Now, I would like to introduce Mr. P.K. Das, our guest of honor. He is a former president of IIW Kolkata branch. Mr. Das is a graduate with honors in metallurgical engineering from IIT Kharagpur and also a graduate in operational research with specialization in marketing, an international welding engineer, and a fellow of IIW-India. He has 49 years of experience in welding technology and related areas, spread over reputed organizations like ACC Vickers Babcock Limited, now as from India, Indian Oxygen Limited, now Praxair India, SF India Limited, and the Valency Group, and he held senior level positions in development, technical services, quality assurance, marketing, and sales. He has been associated with the Indian Institute of Welding since 1973 and headed responsibilities like Chairman, Welding Education Committee, Chief Editor of Indian Welding Journal, and Vice President before he became the President of Institute during 2012 and 14. He also served as the international advisor of the American Welding Society during 2012 to 2017. Mr. Das has presented several technical papers in national and international seminars and was the recipient of Golden Jubilee Ratna Award of Indian Institute of Welding. Presently, he heads the skill development activities of Indian Institute of Welding and also an advisor to the Valency Group. Sir, I would request you to kindly address the audience. You can take over from me now.
I'll just take some time to share the screen.
Sure, sir. Sure.
I think it is visible.
Yes, sir. It is visible. You can.
Okay.
They can maximize it.
Is it okay?
Yes, sir. It's very fine.
Thank you.
You can go ahead.
Honorable Chairman, sir, Honorable Vice Chancellor, sir, the dignitaries of C.V. Raman College of Engineering, my colleagues, including Professor G.L. Datta, Chairman of Kolkata branch, and other officials, dear students, I'm very glad today to be addressing to you on this very joyful occasion of inauguration of the students chapter. I remember it was about 2 years back when a program under the auspices of Bhubaneswar branch jointly with C.V. Raman College of Engineering was held at your college. And when I had the opportunity to come and see the excellent facilities of welding that has been set up over there. And this is will provide an ideal platform for the students in C.V. Raman College of Engineering to progress in their career path step by step, as is shown here. Now, as I'll make a small presentation, but I'll also speak something about how the students can really utilize the facilities and resources, the faculties and everything available in your college and make a significant jump, significant leap forward in their career. You know, so many students pass out in engineering every year from so many engineering colleges all around the country. And there is a glut of engineers. But in this situation, what every student should try to do is to do something extra. There is no scope of, just sitting or standing or walking. It is a time for running, and not only running, running faster. So I'll just tell you a little bit about what the opportunities are, something our chairman has already introduced to you. Let us go through the yesterday, today, and tomorrow of welding science and technology. Mind the word science and technology. Welding, it was an art to begin with. It was science that it developed it, and it is technology which will drive it forwards in the years to come. And mind the color of those words, technology. It is green. So today, whenever we talk of technology, it should be green. And the glorious journey of welding continues. Little bit of history of welding. History is always fascinating, and so it is for welding also. Dates back to 4000 before Christ, and the Egyptians had already developed the art of welding. And what is welding? What is the conception of welding? That is that is uniting of two or more parts by heat or by pressure or both. The head of sarcophagus of Tutankhamen, that is in the year 1361 to 1352 BC when he ruled, and whose tomb was developed in 1922 in the Valley of the Kings, is a very good example. You can see this. So this was, made of gold and several other copper and other things. So it was from that time the concept of welding came. And another notable example from the history is the famous Colossus of Rhodes, which was built in 292 to 280 before Christ. In its time, one of the seven wonders of the world. This is the one. And coming back to our country, in 310 AD, the iron pillar, the Ashok pillar of Delhi was fabricated using iron billets. Blacksmiths forge welded the structure, which is approximately 25 feet high and weighs around 6 tons. So this is really a marvel of welding. So this is the history of welding in the BC and AD period. Thereafter, in the Middle Ages, the blacksmiths of the Middle Age welded various types of iron tools by hammering. The welding methods remained more or less unchanged until the dawn of the 19th century. Late 19th century, engineers, scientists apply advances of electricity to heat and join metals. And the important personalities in this are Joule, La Chatelier, etc. And early 20th century, prior to the First World War, welding was not trusted as a method to join the two metals due to the crack issues. But 1930s and 40s saw a giant leap, and industrial welding gained acceptance and came to be used extensively in the war efforts to build tanks, aircrafts, ships, etc. The use of welding in today's technology is just extensive and remarkable rise since about 1930. A lot more could be said about the developments, but time is the crucial factor. So I just briefly introduced you to the welding history, Middle Ages till mid 20th century. And now, as Professor Datta has told you, almost all industries use welding for fabrication, repair, maintenance, etc. For joining, building up, overlaying, cladding, rebuilding, hard facing, surfacing. And there is obviously, you can understand, dear students, a very good demand for welding engineers, welding supervisors, other welding personnel welders. And this is proven by various surveys. And you can see from the pictures, industries where welding can be seen, almost all. Moreover here, this is coach body welding, is application in railways. This is a wagon body, also in railways. And this is ship and hull welding. So in the shipbuilding and offshore sector. And this is NASA's Orion spacecraft industry. Coming back to our country, our own spacecrafts, we have sent spacecrafts to moon, to Mangal and all this. And we are also extensively used the modern and most advanced techniques of welding, and which is really, a success story for India. And this is in aircrafts and aerospace engineering. And this is in mining industry, the excavators. And this is in construction engineering, construction industry, structural fabrication. The bulk of the welding is used over here. And this is a welding of power plant. Here also, various types of welding materials and welding consumables are used. And this is also fascinating, underwater welding. So not only that you can weld above water everywhere in the space, but also underwater. And this is fascinating, isn't it? And this is in warfare, welding of water tanks, Several of them may be in use very soon in the Chinese border to give a fitting reply to the Chinese. And this is in offshore pipeline and platforms. Cutting is also an integral, has integral connection with welding. Unless you cut the metal to size and shape, you cannot do a good welding. And sophisticated methods like plasma cutting, laser cutting, water jet cutting, and all this are very extensively used these days. And I'm just showing you a glimpse of it. This is a plasma cutting setup. And now welding is no more dependent on the stick welding or the stick welder. It has come a long way. We are extensively using robots in welding. And you would be surprised to know that number of robots which are in use in India today runs in thousands. And India is assembling robots for welding also. So, steel consumption and welding has got a close link. And here, what is happening is the development of welding and requirements, critical requirements of fabrication. There is increasing steel consumption in the area of high tensile and corrosion resistant steel. One of the objectives in any fabrication is to reduce the weight and increase the strength. So more and more high tensile steels are being used, and also corrosion resistant steels. We don't want to use much of paint. Why don't we have, that is why we used corrosion resistant steels, and for that also you have to know how to weld them. And there is growing use of higher tensile and corrosion resistant steels, along with increased use of stainless steel in construction and transportation. Example, chemical plant, railway coaches, etc. The next is a need for increased productivity. As I just touched upon a little while back, productivity is the factor. And not only productivity, it is coupled with higher quality and overall reduced cost and overall efficiency. And so there is also a continuous development of welding processes. Later lectures, you will hear about that. And these welding processes give you better quality and productivity along with reduced cost. And then all this just felicitate creating of high demand for welding experts, and the field is open for you, dear students. Thus, apart from the bulk demand for welding personnel to match the growth in steel, there is a need for people with greater technical knowledge and expertise to match the requirements of these advanced materials and processes. In India, there is a huge shortage, starting from shortage of skilled welders and skilled welding operators. And in fact, it was around 10 to 12 years back when the then Prime Minister's office, when Dr. Manmohan Singh was the Prime Minister, he had called Indian Institute of Welding to make a white paper about what is going to be the projection of projected requirement of welding personnel, and the consequent how do we develop welders and also welding experts. So this slide you have seen briefly, I'll just explain. So why welding? Why should you go for a welding career in preference to others? When you choose a career, it is not just the pay package. Pay package is high, but you have no satisfaction. This is not a good career. So first of all, at least if it was me, I would look for nature of job, and I'd go for a job. I'll go for a career where I can use various skills, various knowledges. And as Professor Datta has told you, welding is a multidisciplinary subject. So this will always should attract you. And technical content for that reason is very high. And welding technology is already in very advanced level. And every day there is some upgradation is being done. So obviously this leads to more interesting career opportunities. Almost all manufacturing processes need welding, and industries are recognizing need to employ specialized persons. So it gives you good career progress. As the requirement of qualified and trained persons are ever growing, the growth prospects are also very high. And pay packet, since it is a specialized subject, equal or better than other engineering disciplines, pay packet you can expect. In fact, even the welders, skilled welders, they can earn in lakhs, even in India, and not to tell, I mean, not to mention about Middle East and other overseas countries. Then job satisfaction, about which I was telling you. At the end of the day, after hard work, you come back home. You should be satisfied, and you should be satisfy your family, and your family is a part of the nation. So job satisfaction evolves from tremendous contribution a person can make in successfully welding new materials, new processes, new alloys, and using sophisticated techniques. So all these things make welding a very, very noble profession and with enormous contribution to the nation. So welding offers career opportunities for engineers from different streams. I'll come to that. Also, there are opportunities for higher studies, postgraduate studies, and research in welding technology. This is ever growing in our country today. More and more newer materials are being developed. More and more different processes are coming, automation is coming, robotic welding is coming, and there is need for higher and better for more and more research. So a mechanical engineer, how can he be utilized in welding technology? In fabrication shops, in maintenance shops, in consumables marketing, equipment marketing and servicing, inspection and quality control, design, teaching, and training. A metallurgical engineer, R&D laboratories, consumable development. In fact, my own career started very soon after I passed out in consumables developments. In those times, 1970s, earlier India used to import all welding consumables from abroad. And then when it started being developed in India, the main challenge came how to utilize Indian raw materials like like limestone, fluorspar, rutile, and feldspar, and things like that. So this was the challenge. So I started my career in consumable development. Then in fabrication shops, also there is metallurgical engineering is very much required, consumables marketing, teaching, training, etc. Electrical engineer, a lot of contribution he can make in equipment design, marketing, servicing, automation, mechanization, robotic equipment design, marketing, servicing, well tracking equipment, etc. And computer science engineer, also in robotics, automated computers processes, manufacturing, quality control, software development, programming, numerous welding applications and simulators. And electronics and communication engineer also, similar functions. And mechatronic. So this is for programmable, this is for automation, mechanization, robotics, and measuring instruments. So as I said that it is a multidisciplinary subject, but unfortunately what I find from my experience, I have been moving around various engineering colleges in India and giving several similar lectures to attract new people, young people and in welding. But I find that such programs are organized by mechanical engineering department only. Now this practice should be changed in every engineering college. As I have shown you, all the departments should be involved because an electronics engineer is very much a necessity. Electrical engineer also very much a necessity. And also not only engineering, in those institutions where science subjects are taught, I think in your college also, the students who are learning physics, chemistry, they are also very much required in the field of welding. So the tomorrow, I have touched upon yesterday, today, and now going to tomorrow, we are going to the fourth industrial revolutions. The earlier three revolutions changed the fabrication industry as a result of mechanization, electricity, and IT. And the fourth revolution is synonymous with introduction of IoT, that is Internet of Things. And also the latest buzz is artificial intelligence. It is also very much on the cards. In fact, already it is being utilized. So industry 4 is the current trend of automation and data exchange in manufacturing technologies. It includes cyber physical systems, Internet of Things, and cloud computing. Industry 4.0 creates what has been called a smart factory. Looking ahead, World 4.0, the Internet of Things and AI, is on the horizon. So finally, IIW talking about those who wants to pursue further studies, we conduct AMIIW examination. This is associate membership of the Indian Institute of Welding. This is equivalent to degree level course in welding engineering. Now students in third year can join this and take this additional subject of welding. Even before, as your VC has said that he has a very ambitious plan to introduce welding engineering as a full engineering course. But even before that, you can join this and appear for some of the additional papers while you are continuing your usual study and get this additional degree, which is equivalent to degree level course in welding engineering. And also, you can pursue International Welding Engineer of the International Institute of Welding. It's a postgraduate level course. So I appeal to all of you, join Indian Institute of Welding. You have already joined, you have become a member of students chapter, but continue this membership for throughout your career and for enhancing and enriching your professional career in welding technology, because welding is exciting and it is so vital for the growth of the country. And I think I'd like to mention one more thing, that Indian Institute of Welding, apart from the various competitions that we are organizing, as Professor Datta has said, we have also introduced Young Entrepreneurs course. As our Prime Minister has rightly set in the concept of self-dependence, which will also promote manufacturing in India for the world. So for this, we need entrepreneurs, not only job seekers. We also need entrepreneurs. And even if you are doing job, you should have an spirit of entrepreneurship. So for this, welding is exciting and very vital for the growth of country, and that is why the motto or the tagline of our institute is welding for nation building. And finally, it is not anymore the dirty or the dangerous jobs as the perception still persists. And I remember that when I visited your college only, some people mentioned that even now in the village areas, rural areas, people do not consider welders as good bridegrooms because they feel that it is a dangerous jobs. And also they feel that not only they, even engineers also feel that it is dirty and not white collar. Well, it is now cool and smart. So thank you very much for your patient hearing.
Thank you very much, sir, for such a nice presentation about the global and national welding history and various applications from years together and to continue, which is going to continue till ages to come. Thank you very much.
Thank you.
Now, I would like to introduce our the second guest of honor, Mr. Vijay Vadeka. Dr. Vadeka studied metallurgy at the MS University of Baroda, received bachelor, master, and PhD in metallurgical engineering. Presently, he is working as professor and head of the Department of Mechanical Engineering at School of Technology, Pandit Deen Dayal Petroleum University, PDPU in Saur, Gandhinagar, India. He received funding from various funding agencies like DST, ISRO, DRDO, and DAE for his research in this area of advanced welding processes. So far, he has completed 5 sponsored R&D projects and 4 ongoing projects. He has guided 27 MTech and 10 PhD research scholars into his credit in the area of advanced welding processes. He has published 70 international journals publication he has got under his belt. He has 2 Indian patents on the narrow gap welding torch and torch oscillation device. He is a member of various professional bodies, which includes IIW, ISMT, IST, IIM, and lots more. Now I would like to invite Professor Vijay Vadeka to take over and give away his speech. Sir, please.
Yeah, thank you very much. I'll just share the screen and
Yes, sir.
yeah. So can you please confirm the screen is visible?
Uh, yes, sir. Now it is visible.
Okay, okay. It is in the slideshow mode.
No, sir. You have to put it in the slide, sir.
Okay, now?
Yes, sir. Now it is fine. You can go ahead.
Okay, okay. Good afternoon, respected official from CV Raman Global University and IIW members. Myself, Vishwesh Badeka, and I have been given the responsibility to talk about the student chapter activities. So, in fact, I would like to tell you that my journey started when I was an undergraduate student. When I was in 1998, I was a pre-final year student, and my professor told me to about the IIW, and then I joined the IIW professional body. So from that 1998, the journey started, and today I'm in front of you. So I have been given the responsibility to talk about the activities that currently we are doing under the various students chapters. So, so let me share some of the students chapter activities that we are doing. So under the IIW Baroda branch, there are 4 students chapter, and in total under IIW India, we have now with this 12 chapters. So there are 4 chapters we have currently under IIW Baroda branch. They are affiliated with the various colleges, including PDPU Gandhinagar, where I am currently working. And there are other 3 chapters with the ITM, Parul, and the Marwadi universities. And there are 2 of them are in Vadodara, where our IIW Baroda branch is located. And one is in Gandhinagar and one is in Rajkot. So when it comes to the activities, I would like to share some of the activities that has been done under the IEW chapters. So this is one of the activity which was carried out where the students are getting hands-on training to get an idea that what exactly the skill level required while performing the welding using various arc welding processes. Additionally, another activity which was related with the in collaboration with the Fronius, where the students are getting exposure about the advanced welding processes, the intelligent MIG-MAG welding processes that was organized, and the students are getting more practical exposure. Sometimes it has been observed that the university has a limited resources. So in collaborating with the other professional organization, such workshops were arranged. So industrial visit is also part of the requirement. So students or a group of students, they visited the various industries, including the L&T heavy engineering. And this visit was carried out by Parul University chapter. And faculty members were also part of this particular chapter. So students get an idea about the practical knowledge in the area of welding. There are some experts were called by the university to conduct certain expert sessions in the area of advanced welding processes. Then students, there were also some other expert lectures were delivered by the other faculty member of the university into the Parul University. So students are listening to those expert lectures very carefully. And then there is another lecture, another practical requirement, which is called WPS PQR requirement, which was carried by our own IIW executive committee member, Mr. Kashyap Bhatt, and he taught the students about WPS PQR requirement, which is very important when the students are getting knowledge before they really jump into the industry. Similarly, there is another student chapter, which is ITM. So in order to emphasize about the welding, they conducted the welding quiz. And that quiz, many students participated in this quiz, and to make them aware about the welding knowledge in that particular area. Then they also organize industrial visit, and this industrial visit was carried out at Inox CVA, which is again in close to Vadodara, where our Mr. D.V. Acharya is heading the Inox CVA as a COO of the company. And the students of ITM, they visited this particular plant and understand the various operations of welding involved in manufacturing of cryogenic vessels. Then faculty delivered the lecture on role and responsibility of the welding inspector. That was there. Additionally, nowadays, we are talking about 3D printing, additive manufacturing. to make them aware, students, make them aware about the various concepts of additive manufacturing and 3D printing. That hands-on training workshop was carried out by the ITM Universe. Then I will be sharing some of the activities which has been carried out by PDPU. So we had activity in the area of non-destructive testing, and the students, they got the hands-on training in operating the various non-destructive testing equipments, like say for example DPT, MPT, LPT, and they also get an idea about the radiography film viewer, how to read the radiography films and identify the defects. Additionally, we conducted one skill development program. So during the summer, especially during your regular session, the students are not getting that much time to operate the machine. So during the summer, we conducted the skill development program. So students are getting hands-on training depending on their interest. They normally take the skill, whether they would like to take welding, machining, non-conventional machining, CNC machining, and they spend the entire 5 days in that particular skill and enhance their understanding, practical understanding, operating those machines. Then we also had a expert session in the area of structure property correlation of the friction stir, and that was held in the month of September by our Mr. Gaurav Rao is from Naval Material Research Lab, and that expert talk was delivered by him, and it was a very informative session, that friction stir welding for high temperature materials. Then the students also had an opportunity to visit one company which is called Sarjana Laser, and our MTech students, they visited this particular company and understood other than laser has normally, we talked about machining, we talked about welding, but laser has other multiple applications also. So through this visit, they particular students had an opportunity to interact with the company official, and they got a practical exposure about the laser and its allied applications. Then we had a lecture by Dr. Krishnan of ex-BARC, and that lecture was on latest research applications in electron beam welding. So that was also delivered by Dr. Krishnan, and that was last year. And then we had some of them international speakers also visited PDPU, and we had an opportunity to have Dr. Antelino Australia from University of Nepal, and he talked about powder-based additive manufacturing process. And students had a practical exposure, and he talked about his research as well. Then we had very good collaboration with Siemens. So Siemens official visited, and he talked about project management, because this is an additional skill which is required by the students to understand. So project management was also, talk was delivered by the Siemens official. We also had another official from Kalpatru Power Limited in Gandhinagar, and he talked about optimization techniques used in industry. It was well received by the students, and probably around 60 plus students participated. Then in order to motivate the students had given the opportunity to talk about their own interest. And so we arranged a young professional seminar, which was delivered by the PhD scholars only, and that was attended by the MTech scholar. So young professional seminar was organized, half a day seminar, 2 to 6, and we had a 4 talk in the different areas of metallurgy and welding. Then MTech students also had an opportunity to understand the various ASTM standards, because in our curriculum, we don't have that much stress on ASTM standards. So various ASTM standards were selected by the students, and we had an interaction followed by presentation on each standard by each of them. And that was well received by the students on that day. We also collaborated with the nearby university to conduct certain joint activity. So we conducted one activity which was a 3-day event, a joint seminar with the college called BITS Education in Vadodara. And it was a 3-day event which was collaboratively done. And faculty from PDPU and the other faculty, they participated in the event. Then we had another international speaker, Professor Anil Kulkarni. He from Pennsylvania State University. He was in India, and we had an opportunity to listen his research in the area of interdisciplinary research, the field assisted sintering technique. So that was delivered by him, and we had a very good interaction on that day on his research. Then Professor T.K. Pal and Professor Zen Chen, they were in Ahmedabad, and they visited PDPU, and followed by visit to the Welding Research Lab. And Professor Zen Chen delivered a talk on solidification behavior of the powder bed fusion. and metal additive manufacturing. So Professor T.K. Pal was also there, and we had a very great interaction on that day, followed by visit to Sajan Laser as well. Then we had Professor G.G. Roy from IIT Kharagpur. Professor G.G. Roy is the Assistant Dean at Kharagpur. And Professor G.G. Roy visited in the December 2019, and Sir delivered a talk on role of fluid convection in the fusion welding processes. That was also well received, and many students attended this particular talk. Then we have an Institute for Plasma Research very close to PDPU. And on the National Science Day celebration, we organized a visit to the Institute for Plasma Research. And it was like about half a day visit to the mainly MTech students visited that particular research center. Then we had a Professor Bhubaneswar Rao. Bhubaneswar Rao visited PDPU, and he delivered a talk on friction stir welding of ferritic martensitic steel. And just before the lockdown in the month of February. So that was probably our last activity before the lockdown. And in the month of February, I had an opportunity to attend IC 2020 at Bombay, and had an opportunity to deliver a talk on various students chapter role and responsibility of IIW towards the students chapter. So that was done, and it was well attended by President IIW as well. Then we had in the month of February, we had another joint activity, which was in collaboration with another government college in Gandhinagar. And that was a joint seminar in the area of friction stir processing. More than 60 students attended that, including PDPU students and government college students. And then there is another private university in Vadodara, which is called GSFC University. And that GSFC University organized one seminar on emerging trends in mechanical engineering. And there I had an opportunity to deliver a talk, and which was to motivate the young professional in the area of welding, and which was attended by our IIW Baroda branch chairman, Mr. Hiren Patel as well. Then, as I mentioned, there are other students chapter we have nearby, say from Rajkot and Parul University in Vadodara and ITM in Vadodara. Say they also visit PDPU, and we do exchange in terms of we have a research facility at PDPU. And now in the lockdown period, in fact, it was very difficult to carry out the activity. So then we started a webinar series. So we conducted webinar series, and that webinar series was supported by our own MTech students, because sometimes, students may not have that practical exposure that how to make a presentation on a webinar platform. So that to make them aware about that part, additionally to understand their technical know-how of the topic. So we conducted, say for 8 webinars were conducted in the different area, and these all speakers were our own MTech students of mechanical engineering in the area of manufacturing. And from 10th of May, in the lockdown period, from 10th of May to 27th of June, we conducted various webinars, and those webinars were delivered by our own MTech students, and there are a number of participants at the state level or national level, they participated. So these are some of the glimpse of those webinar announcement. And just to give an idea, that actually announcement was made, and it was available well in advance, and we had a very good participation from across all the students chapter. Additionally, we also conducted certain webinars by the PhD scholars. So those who have completed the PhD and those who are currently doing PhD in the different area. So we conducted 4 webinars. They were all by, previous one were by MTech scholars. Now these 4 were conducted by PhD scholar in the advanced topic of welding. And we had a number of participants here, like 5th July to 24th July by PhD scholar. So these are some of the announcements for them. We had Dr. Rana, Dr. Kunal Mehta, Deepika, and Dr. Pratiksha. So now I have completed the activities part. So as I mentioned, this is now we have, these are all chapters and the students chapter and the list. Now in Baroda branch, we have recently inaugurated one more chapter, which is on NIT Surat, which would be a new addition into Baroda branch. Recently, it was inaugurated. And these are some of the guidelines which has been there for best performing students chapter by IIW-India. Like their criteria are like memberships, activities, participations, reporting to mother branch. So these are the certain criteria which has been worked out by the IIW-India. And the period of activities is mainly from 1st October to 30th September. So then for each activity, there are certain marks are assigned. Say, for example, membership, then activities like expert talk, industrial visit, quiz competition, seminar, workshops. Then third is participation, reporting to the mother branch. So these are the criteria. And at Baroda level, they conducted this particular activity, and PDPU branch received the best performing chapter among all 4 chapters. So with this, I have come to an end of activity, and thank you everyone for giving this an opportunity to share the various activities under the banner of IIW India. Thank you very much.
Thank you, sir. Thank you for highlighting some of the activities of IIW with various student chapters, which will be definitely encouraging for the students presently. Now, I would like to introduce our next guest of honor, Professor Santanu Das. Professor Santanu Das works as a professor and head of the Mechanical Engineering Department in Kalyani Government Engineering College, India. Previously, he served at Project and Development India Limited, New Delhi, and Dr. Babasaheb Ambedkar Technical University, Loner, Maharashtra. He did his bachelor's and master's in mechanical engineering from Jadavpur University, Kolkata, and obtained PhD from Indian Institute of Technology, Kharagpur. His areas of research include welding, cladding, grinding, machining, inventory management. He has to his credit 171 publications in journals, book chapters, 84 papers in international and 141 papers in national conferences. He edited so far 10 books and guided 6 number of PhD theses. At present, 10 PhD candidates are being guided by him. He is now the Secretary of Institute of Science, Education and Culture, Chief Editor of Indian Welding Journal, Editor of Journal of Association of Engineers, Indian Managing Editor of Indian Science Cruiser. He also edited jointly a Reason, a technical journal. He was Editor-in-Chief of the Bulletin of Association of Machines and Mechanisms for about 5 years. Since July 2018, he is also the President of Kolkata chapter of Indian Institute of Industrial Engineering. He received some of the awards for Best Research Papers and Shiksha Ratna in 2018 as an outstanding teacher from Education Department, Government of West Bengal. With this introduction, I would like to invite Professor Santanu Das. Sir, please, you can take over from me.
Yeah, let me share the screen first.
Yes, sir, please. You can put it in the slide.
Can you see it now?
Yes, sir. Now it is fine. Yes, sir, it's fine.
So I start my presentation. First, I thank CV Raman Global University to come up to start and install the students chapter under the aegis of the Indian Institute of Welding Kolkata branch. I am very much thankful to the chief guest of CV Raman Global University, Mr. Sanjeev Kumar Raut, Honorable Vice Chancellor, Professor Bhubaneswar Bhattacharya, all the other faculty members, officers, and students of this university to come up and start this students chapter. Also, I thank the office bearers and members and others of the Kolkata branch of Indian Institute of Welding to come up and join hand with this university to start functioning of this new students chapter in this eastern region of India. So without wasting much time, I start my presentation. My presentation is on basics of welding. And whenever we start talking about basics of welding, obviously we should first know that what is the basic definition and characteristics of the process of welding. By this time, today we have seen and we have heard a large number of lectures by the luminary figures in the areas of welding. And it is started with Professor G.L. Datta, who has long been associated with the areas of welding, doing research, training, education. Also, we have heard about different career opportunities told by Mr. Pavitra Kumar Das, past president of the Indian Institute of Welding. He has also been associated with this process of welding and its development since long. And also, just before my lecture, we have heard about the different types of activities that is done by PDPU under the guidance, able guidance of Professor Vishesh Vadeka. And lot of activities can be done in the activities of the students chapter. So this new students chapter can also chalk out the plan to start different kinds of activities in the areas of welding. Now, come back to the process of welding. We have learned about welding. We have seen the welding processes going on here and there. Many persons are doing welding for making the steel gates, steel grills, and all these things here and there. And we know that this is the process of welding. And it is also interesting to note that this welding can be practiced. Welding can be practiced by one illiterate also, a trained illiterate person who is not knowing even the 3 arts. As at the same time, welding can be one person's profession in the high level of research, education, industry, etc., etc. So coming back to the process of welding, welding is basically characterized by these following aspects. I have just jotted down 5 different aspects of welding. That welding is a basically manufacturing process. And this manufacturing is not the manufacturing of agricultural products, potatoes, paddies, etc. But it is the manufacturing of mechanical components. Now it is making a permanent joining. That is another important aspect. Then it is having the capability to join similar or dissimilar materials, also for metallic materials and also for non-metallic materials. Then it is making the joint. It is very important characteristics of the process of welding, that weld bead or coalescence is getting formed during the process of welding. And it can be done with or without the application of heat, pressure, or filler material. So these are the basic characteristics of any welding process. And let me see, what are the basic features? Now you can see in this particular diagram that this is the basic block diagram of any manufacturing process. And which manufacturing process? It is the manufacturing of mechanical components. So for any mechanical components, while you are going in for manufacturing, it should start with the raw material. So there should be some raw materials. It can be liquid, it can be solid, it can be powder, it can be semi-solid, whatever it is. So these raw materials are processed, and this processing is nothing but the manufacturing process of mechanical components. And then you get some product, and this product will be having some specified size, shape, dimension, accuracy, and other properties. And this is the basic block diagram of manufacturing process, and welding obviously is also one kind of manufacturing processes. Next, we see what is the basic aspect of or basic system of your coalescence or weld bead formation. We can see here one welding process is going on, and out of this welding process, we have seen here one typical weld nugget is getting formed, and this weld nugget is nothing but the weld bead or coalescence which is getting formed during this kind of welding process. Now we make the definition very concrete. What is it? Welding is a type of manufacturing processes in which permanent joining of similar or dissimilar materials. That means it can be either metallic materials or non-metals. And it can be done by the formation of weld bead or coalescence with or without the application of heat, pressure, or filler material. So this is the basic definition of the welding process. Now, if we come to the next part, that how the welding processes can be classified. Broadly, welding processes can be classified into 2 areas. One is solid state welding or solid phase welding, in which no melting or fusion of the faying surfaces are occurring. And the second type is fusion welding. The name suggests that here melting or fusion of the fairing surfaces happen, and then subsequently it is getting solidified, thereby making the welded joint firm and very good. Now, whenever we come to the solid state or solid phase welding processes, we are now having several types of processes. And if you see the chronological developments and discoveries of these processes, you can see these processes started almost from the year of 1905. But if you can recall, whatever has been told by Mr. Pavitra Kumar Das, that even before these processes, there were very old processes like forge welding processes. And
Sir,
even,
may I interrupt you?
yes, please.
Your slides is not proceeding. We are still at the second slide, I think.
Oh, just a minute. Oh, okay. You share. Okay, I'm just again sharing it. Just a minute. Somehow it is okay. Are you seeing now?
No.
Hello.
It's the same slide.
Same slide. Okay. My slide is stopped somehow. Anyway, I'm just trying again. I'm again trying. Can you see my slide now?
Yes, sir. Yes, sir.
Okay. I think this one is discussed already. Is it now progressing?
Yes.
It is progressing.
Yes.
Which slide is seen now?
Manufacturing of mechanical components.
Okay. I have already discussed it. Then I am proceeding. This is the basic weld bit formation, which is seen here. And next, the definition. I think already I have covered it. And now, okay, I am repeating from this again. Okay. So this is the basic classification of the welding process. And we classify welding in two ways. One is your solid state welding process, in which no melting or fusion of the fairing surfaces happen. And the other process is fusion welding, where joining is done by melting or fusion of the fairing surfaces. And these fairing surfaces are the surfaces which are actually joined to make the welded product. Now, these are the various developments. These are the various developments of the solid state welding processes. And while I discuss it here, you can see that 1905, where resistance spot welding was discovered. But well before this particular year, we have seen the basic presentation of Mr. Pavitra Kumar Das, that he mentioned that in the ancient ages, even before the Christ, there were welding, and they were basically the forge welding processes. And we know this forge welding is the oldest welding process, and that is also one solid state welding process. So it is so old, it is not shown in this particular slide. So we start with the modern kind of welding processes, which has been discovered since 1905, where resistance spot welding was discovered. Then a lot of friction welding processes was discovered after a few years, and then explosive welding in 1963, ultrasonic welding in 1965, resistance seam welding 1967, friction star welding, relatively new process, only in 1991, around 30 years back, it was discovered, and then friction plunge welding was discovered. I will not have the scope to discuss all the processes because time is very short. I have chosen few of the processes that I will discuss and I will show, and then I will switch over to the next portion. Now, in this particular diagram, I am showing a diagram of the resistance spot welding, and I hope in most of the universities and institutions, this particular setup is available, and students will be exposed or have been exposed to this particular process. And mainly sheet materials are welded here, and two electrodes are there, one at the top, one at the bottom, and current is passed through these electrodes, and ultimately through the resistance, that is I square RT, that R is the resistance and I is the current. Very high amount of current is passed, and then resistance should be much, and then within these two sheets, the weld bit formation can be formed. And if it is a solid phase welding, if it is fusion welding, both the processes can be possible using this particular type of process. Depending upon the amount of current and resistance, you can switch over from the fusion welding process or in the solid phase welding process. Both are possible depending upon the current, temperature and other systems. And pressure is applied, and ultimately this particular joining is done there. And here you can see that I square RT current is set very high, more than or around 10,000 amperes can also be possible. And square of that will be a huge amount of power and energy which is coming into the system. And then resistance, the contact resistance between the two sheets are responsible for giving you the heat, and you are allowing some amount of time under pressure. It is allowed to be there, and then the joining is made. Next process you can see, or rather next diagram you can see, these are various products what you can make out of this resistance spot welding. These particular handles of a dish or of a particular pot, that can be very well spot welded. At a circular spot, welding can be done. Even a particular cylinder, some pressure vessels, etc., can also be done welded using this spot welding. Obviously, pressure vessels are not usually done, because if it is a high pressure system, etc., and their seam welding is required. But some of the vessels that can be easily joined using this resistance spot welding processes. Now I come to another process which is known as the friction welding process. Here, friction energy is required to generate some amount of heat, but it is not so high amount of heat that it melts. But this heat is sufficient enough to make it in plastic state. Then you apply pressure, and then the joining can be done. And this can be done in a particular setup like a lathe. That say in one chuck, you are holding a particular rod, it is rotating, and then in another place, maybe in the carriage, etc., you are holding one rod, and this rod can be pressed against the rotating on, and then lot of heat will be generated. And then at a particular stage, you just apply brake there, stop the rotation, apply pressure for more time, and then you will find a particular friction welded product is made. So this is having some typical other dedicated machine also, but in a lathe also this can be carried out if you can design a timer and a proper braking system. And these are various kinds of components that you can make using this kind of friction welding process. Another process, a recent one, that is friction star welding process. Here some tools are used, and these tools can be very high temperature resistant tools, maybe tungsten carbide or so, and various types of similar as well as dissimilar materials can be joined using this friction star welding process. And here aluminum, lead, magnesium, zinc, even some soft category of steels can be welded. Even steel to aluminum, this kind of dissimilar welded joints can also be made using this friction star welding process. And this is the process schematic in short, where the tool can be inserted within the material to be joined, and the tool part, that front part, pin part, will be going inside the particular process, where inside the particular job which are to be joined, and then the tool, while it is rotating, will be feeding from one particular position to the other position, and thereby through solid material, plastic solid material mixing, and then subsequent solidification, it can be rather subsequent cooling, it can be joined. This is a very new process as such, and it is known as a friction star welding process. Very promising process also, because this process can be used for dissimilar material joining, which are as such not weldable. That can be also welded using this particular type of process. This is very important process nowadays. Now I come to the various fusion welding processes. We start from the carbon or graphite arc. It is also a non-consumable type of arc welding machine, arc welding system, where graphite or carbon electrode was used, and it was discovered long back in 1887. Then thermit welding, you are knowing it is a through chemical reaction process. We are having this thermit welding process done, and this is 1896 that was discovered. Then gas welding, 1903. Again, resistance spot welding I am put here because it can also be used for fusion welding. Then shielded metal arc welding or manual metal arc welding, which is commonly known as MMAW or SMAW process. Because in all the engineering colleges, whenever we are entering in the first year or second year level, we all practice this particular process of our own hand, and we use there some stick type of electrode, and this electrode is having a sufficient or rather finite length, and you can do that welding process. First welding process what we do in our laboratory or workshop is this MAW or SMAW process. Then we are having also one improved version, that is metal active gas welding. This is coming under a broad category known as GMAW, gas metal arc welding process. 1928 it was discovered. Then submerged arc welding process, SAW, 1935. Then TIG welding or GTAW, that is tungsten inert gas welding or gas tungsten arc welding process in 1947. So the year of independence of India, that time this particular process was discovered. Next year, MIG process or GMAW process, that is metal inert gas welding. Argon gas was used that time for this particular welding, 1948. It was discovered. Then FCAW, flux cored arc welding process, discovered in 1965. Resistance seam welding, 1967, that were discovered. And now I am putting another 3 processes here. These processes are relatively new process. Plasma arc welding, 1963, electron beam welding, 1965, and laser beam welding, again in 1965, it was discovered. And mind that these processes, plasma arc welding, electron beam welding, and laser beam welding processes are all coming under high energy density processes. High energy density processes, very important processes, very important processes. Next. Now come back to the arc welding process. Very important welding process, and majority of the welding processes are based on arc welding processes right now. And in this particular case, what is happening? The workpiece and the electrode are made to be 2 different electrical polarities, either plus or minus. And in between 2 electrodes, current is passed. And this current is nothing but the current is making the electric arc by making the in between gas ionized. And you can use either a DC, that is direct current, or you can use also AC, alternating current. For specifically speaking, aluminum welding, we normally use AC current, where cleaning action is also done in one particular half cycle, and heat input is done at another half cycle. So aluminum welding is very important, and at the same time, aluminum welding is problematic because aluminum becomes readily oxidized to become alumina. Aluminum is highly conductive to electricity as well as thermal systems, but alumina is insulator. It restricts electricity conduction as well as thermal conduction. So if alumina is getting formed on the alumina, then total electricity circuit is broken, and ultimately your arcing will be stopped. So for that, AC welding is mostly used for aluminum. And in case of DC, we can also use DC-EN as well as DC-EP, that is DC electrode positive or DC electrode negative. If it is DC electrode negative, then workpiece gets maximum amount of heat and workpiece can be melted easily. But for thin sheets, then we have to use DC-EP, while electrode will be getting more heat and workpiece will be getting less heat. Otherwise, it will be all melted. Now we show a particular diagram for your shielded metal arc welding process. I think everybody of you have seen this particular process where a flux is covering a particular electrode, and ultimately this flux shielded electrode is used for your shielded metal arc welding or manual metal arc welding process. And you can see at the right hand side a particular small simulation where the stick electrode is held within a clamp and ultimately welding is done. And you are seeing that there is a complete circuit mesh through the welding machine, and then the table that should be also conductive, and this electrode is also there. So while it is arcing going on, then obviously there is a electrical circuit made complete. Now we can come to the other process, GMAW process, gas metal arc welding process. In case of your shielded metal arc welding, we are using a finite length of the stick, and this stick, whenever it is consumed, we have to throw it off. That means the welding is stopped. We have to take another stick, and then again we can start the welding process. And thereby that starting and ending of the welding is becoming one hazardous part, a defective part. So that particular defective system is eliminated whenever we are using this gas metal arc welding process, because in this particular process what we are using a wire spool, and this wire is coming through a nozzle, concentric nozzle, and outside this wire there will be a supply of gas. So one gas nozzle, at the center of it there is an electrode, wire electrode is coming, that is used here. Wire is continuously pushed by one servo motor system, and the servo motor also controls the electrode tip distance or stick out distance, and ultimately you can get very good, uniform and reliable and very good quality welding possible using this GMAW process. And here the overall GMAW process and its equipment is shown, where one servo motor is shown here, wire spool is there, the gas cylinder is there, ultimately welding gun is shown here, which is doing the welding process. Next process, again it is an important process, very reliable and accurate process, that is GTAW, that is gas tungsten arc welding or tungsten inert gas welding process. In this process you can see here at the right hand side one diagram is shown. The one person is holding a torch here, one ceramic nozzle is there. Within this nozzle at the center there is tungsten electrode, and outside there will be argon or some other inert gases which are supplied, and ultimately welding can be done here. Okay, very accurate welding is done, but here problem is that it is having less productivity. Another process I am showing here, very important process, and that is used for very thick material joining, which is known as submerged arc welding process. Here under the powdered or granular flask, the arcing is done. So arc cannot be seen from outside unless the flux is transparent in nature. But in most of the cases, fluxes are non-transparent and you cannot see the arc. So within the covering of the flask, the welding is done, and you can also make the automation of this particular process, submerged arc welding process as well as GMAW process, very easily. Next. Again, I am showing here the resistance spot welding process, because this process is also coming under your fusion welding process. Another process, it is resistance seam welding process, where long seam can be done, can be welded, and various kind of sheet materials, etc., can be joined very reliably using roller type of electrodes, as shown in this diagram. Another process which is known as resistance projection welding process. In some projected areas, welding can be done and weld bit formations can be done. You can see weld bit formations are made at some areas, at some spots, and that is also possible, and that is known as resistance projection welding process. Now I am coming to some of the processes which are coming under high energy density, and electron beam welding is one such process. And mind that this is highly radioactive in nature also, so you have to make a lot of shielding and all these things. And in case of IGCAR, that is Indira Gandhi Research Institute, Atomic Research Institute, they are using this kind of process, and it is basically restricted to very high, you can say, resolution and accurate type of welding process. Here penetration is quite high, and pencil type of penetration is possible there. So high penetration, low width of the bead is possible using this electron beam welding equipment process. And next I am showing some of the accurate welding which is done through this EBAW process. All these joints, all these components are basically replacements. Whenever we break our bones, etc., they can be replaced. This hip bone, elbow bone joint, etc., they can be replaced within this kind of jointed products, and this joining can be done through EBW or electron beam welding process. Now another important high energy density process, it is laser beam welding process. So laser beam is focused at a particular point, and that particular point gets lot of energy, and this energy can be spent for doing this welding. So we can weld here plastic components, we can weld some metallic components, that is possible. And at different spots, at different areas, we can do the welding process, that is possible. And another process is plasma arc welding process. Mostly it is restricted to very thick material which is getting joined. And this can be direct, this can be indirect. I'm not going into that detail. So plasma is nothing but ionized gas, and through arcing process, this ionization of gas is done. And this ionized gas can be passed and ultimately put into the workpiece, making it melted, and thereby it can be joined through subsequent solidification process. Now I am coming to another part, which is basically mechanization and robotization of welding process. So welding can be done through a skilled operator manually. Also, it can be done through some semi-automatic process, mechanized process, and also through robotic welding process. It is possible. Now, in this particular diagram, we show one particular process, which is a SAW process, submerged arc welding process. And you can see there are some wheels. So one particular welding machine is moving from one point to another point at a particular direction. And this wheel is moving at a particular rate of speed, and vertically downward, there will be the wire coming out. That wire is the electrode wire. And then from an angle, some nozzle is there, which sprays the granules, the granular flask, solid flux material. So whenever the flux materials are covering a particular part, then welding is done. And this is the submerged arc welding, which is mechanized, automated through mechanization process. That is the example here. Next part is the robotic welding. A number of processes can be robotized. Here you can see one laser beam welding process can be possible using a robo. So this is a robo manipulator, and welding torch is held at the end effector position, and ultimately the particular way you want to make it welded at different curvilinear positions, linear positions, the robotic hand can move along that particular direction if you are programming it properly, and then welding can be done in a very accurate fashion. Also, robotics can be applied in a gas metal arc welding process. You can see that torch is there at the bottom part, and joining can be done here on a plate. And there is a big pipeline here, which is actually sucking out the gases what are coming out of this welding process. So through this welding, through this particular robotic system, you can make linear welding, you can make different curvilinear type of welding process possible. Next, I am showing here that riots of welding processes going on through robotics in automobile manufacturing industries. Almost in all the automobile manufacturing industries worldwide, they are using extensively robotic welding processes. Be it a spot welding process, be it arc welding process, they are done. You can see here at the left diagram, one after another, car chassis, car bodies are getting welded. And the right side also, different other welding of door frames, then window frames of one car is going on. And one person is here who is actually controlling and monitoring all the processes, whether it is going on successfully or appropriately or not. They are only controlling it. Now, I am just touching about the definitions of Internet of Weldings. Actually, all these things have been already discussed in the other two slides. Professor Datta has also discussed a bit, and Mr. Pavitra Kumar Das also has discussed a bit. So nowadays, this is one new concept coming on, that while the robotic welding is going on, or other welding processes are going on, all the things are networked through internet processes, through Wi-Fi systems. And ultimately, you can monitor the welding factory, welding process at a remote place. And this kind of integrations can be possible nowadays. Automatic selection of welding process parameters through different kinds of software systems and integration systems are possible. And in that way, we can make it Internet of Things or Internet of Welding that is getting possible in some of the cases right now. And Industry 4.0, also it is discussed a bit. This Industry 4.0 is very much dependent upon IoT and implementation of IoTs. And a lot of interconnections, lot of networkings between one system to another systems, sequencing, scheduling, everything can be done through some computer programs, electronic communications, and remote sensing and remote control systems. So many opportunities are available.
Why stop?
The welding process, its basic metallurgy process, its basic joints, its inspection techniques to different non-destructive testing techniques, etc. That is very much required. So with this, I end my presentation here. Thank you all for patient hearing.
Thank you very much, sir, for a nice technical presentation. Thank you very much. Now we have a small session of student interaction with our eminent members. Now I would like to call Dr. Susavan Basak to kindly take over, and our student representative, Miss Apti Vyas. Miss Apti Vyas, are you there?
Yes, sir.
Dr. Basak, please kindly take over.
Okay, Prasid. Thank you. Apti, we are already running out of time, so just
Yes, sir.
two questions you can ask. So please go
Yes, sir.
ahead.
Good afternoon to all. I am Apti Vyas from final year mechanical engineering student from CV Raman Global University. And my question is, what are the long-term benefits of becoming a student member of IIW-India and how it will be helpful in job perspectives? So please.
I am requesting Rituraj sir. Sir, can you answer that question?
Yes, I can answer, but I think Mr. Devashish Pal is there. He should answer this.
Okay. So Devashish sir.
Yeah, good afternoon, everyone. Yes, a lot of benefits as has been discussed and presented by Dr. Bhadeka. If you have noticed that there are a lot of possibilities that are available to the students chapter of IIW India. We conduct a lot of industry visits. We conduct a lot of lecture sessions because in your mechanical engineering, welding is not taught in so much of details. So when actually you become a member of the Indian Institute of Welding, you will actually realize, all of you will realize that welding is a very vast subject which crosses over all streams of engineering. We will be a little more discussing on this in my speech also, and if you can follow Dr. Vadeka's presentation also. So you must have noticed that there are a lot of opportunities, not only for the mechanical engineers, but also for the students of the other streams as well, because it's pertaining to Internet of Things, as mentioned by recently just by Professor Shantanu Das, and also robotic engineering, as expressed by Sri P.K. Dash. So there are a lot of applications and a lot of opportunities. And if you want to become a robotic engineer also, in case of for welding application, you must understand welding in depth, and also partially weld metallurgy, joint geometry, and the arc physics. So this is only possible if you can get yourself associated with a professional institute like the Indian Institute of Welding.
Thank you, sir. Apti,
Yes,
one
sir.
question, another question.
Yes, sir. So I would like to move forward with one more question, that what is a good approach to be an expert in welding? And if someone says his or her interest in welding art and sculpture, then from where should one has to start?
Can you repeat your question, please?
Can you repeat the question?
Yes, sir. Sir, question is, what is a good approach to be an expert in welding field? And if someone shares his or her interest in welding art and sculptures, then from where one should start?
Can I answer this question?
Yes, sir. Please, sir.
This is a very good question, and she has touched upon a new dimension. Just for your information, in the international conferences and even exhibitions, there is a display booths and competition on welding art objects, and we also started this in during our last international exhibition at Bombay in January, this year January only. So basically, this is some sort of hobby, you know. So what the people do in the West, they buy small inverter sets, you know, very pockets, carryable size, and they do all sorts of welding, like the garden articles and a few other things. So you have to develop this hobby. As such, there is nowhere you can get trained for this hobby. I mean, this sort of art and culture objectives. But you can, start yourself and gradually learn from the references and other things. Okay, thank you.
Thank you very
for
much.
sharing.
Preci sir,
Okay, sir.
you can move forward.
All right, sir. Actually, we have gone a lot ahead of the timing which was to be met. So now I would request Mr. Debashish Paul, Honorable Secretary IIW Kolkata branch, to say a few words. It's a request to everyone, please cut short on your speech because we are actually running ahead of the time. Please.
Yes, thank you. And respected dignitaries of the C.V. Raman Global University, the Indian Institute of Welding, the officials, and students. Good afternoon to all of you. It is definitely a very glad moment for IIW-India Kolkata branch to be a part of this installation of the students chapter. Student chapter provide unique opportunities for networking, mentoring, and bonding over common interests. They provide support both within the student community and to the professional bodies outside the institution. Chapter participation provides a unique combination of social interaction and professional dialogue among peers in their own geographic area. Chapter members' backgrounds represents all facets of welding activities from academia, research background, represents in industry. It will invariably focus on the kind of information and insight that cannot easily be gathered in any other way. IW India Kolkata branch creates the bridge between the student members of the chapter and the professionals and industry associated with welding. This definitely opens up the wide avenue in front of the students in taking up welding as a career, which is evident from the lectures delivered by Professor G.L. Datta, Chairman IIW India Kolkata branch, in his keynote speech, and Sri Pavitra Kumar Das, Chairman Skill Development Committee IIW India, in his speech on career opportunities in welding. Chapter activities are a key component of running a successful chapter. Here are some of the activities IIW India Kolkata branch carries out. Industry visits. Previous year, Kolkata branch organized industry visit for their existing student chapter. It created a huge excitement among the students as they could physically experience for the first time how the line production goes on from blanking to truck loading. This year, due to COVID pandemic situation, we have planned to organize virtual factory visit for our student chapters. We conduct welding quiz contest. We conduct online technical debate. We conduct welding technology day where students make presentation on different topics of welding and the best presenter is awarded with certificate of appreciation with a memento. We conduct different interactive and lecture session on the topics ranging from weld metallurgy, cladding to welding automation. Besides, the student member of the chapter are entitled to certain benefits like complimentary subscription of the Indian Welding Journal, concessional registration fees for participating in any national seminar, paid, webinar, or exhibitions, participation in the Best Welding Engineer competition. Interested students may also participate in actual welding competition whenever it will happen after the pandemic situation improves. In this context, I would like to reiterate that participation of many girl students of C.V. Raman Global University in the women's welding competition organized at Kolkata last year. I would conclude my speech saying that this installation of the C.V. Raman Global University Students Chapter will definitely make the cooperation stronger between the two premium institutes of the country and create an opportunity for the students to take up welding as a profession or for further higher studies. Thanks to all dignitaries, once again, members, and all present here. Thank you very much.
Thank you very much, sir. Now I would like to call Mr. Rituraj Bose, Honorable Secretary IIW India. Sir, please.
Good afternoon. This first President of CVRGU, Sri Sanjeev Kumar Raut, Professor G.L. Datta, first Chancellor of KL University and present Chairman of the Indian Institute of Kolkata branch, all the distinguished dignitaries, guests, and dear students. So I remember the conversation with Sri Raut when myself and our President, Mr. Parimal Vishwas, was there in last 8th of March during the National Welding League of Women Students. So when he just he told us, and we have discussed regarding the students chapter of installation. And immediately after that, I thank you, sir, that you have started the acting this and advised your university to be associated with us, and then we are here now today. Thank you, sir. So, apart from this, we are having long relationship with CV Raman. You know that CV Raman, the Center of Excellence for Welding, is the authorized training institute for of this our skill development programs, and some discussion is going on to be the authorized training body for this international welding engineer and all these courses. And what else that I am proud that some of the students from CV Raman Global University has won the prizes in our national events. Like I can tell that Shubhendu Mollik is there, who won the prize. Then Shorin Das is there, who won the aspirant welding engineer prize. And there are women students, girls are there, so many. Apti is there, Taslima, Vandana is there. So all their enthusiastic students, those who are associated with us now. So I should tell that for the long association of relation with Indian Institute of Welding, all of you, what you should do, you should carry on your membership after passing out also. Then only it will be helpful for you and helpful for us, because this is a professional institute, not a government body, not a private body. And students and other professionals like here all are there. So we made this institute, and it will be or grow up again and again, and this with your help only. So after completion of this also, please continue with our institution as a member. Then only it will be meaningful that to build a student chapter there. And what Mr. Pal has just told, there are so many privileges will be given to you. What was the question of Apti also? So already discussed by Mr. Pal, and Mr. P.K. Das also told regarding the sculpture, art and sculpture. I can add one thing, that as he told that last in International Congress, there was a stall where this art and culture was there, the photographs and real product was there. And from International Institute of Welding, they have just shown the interest to take some of our this art and sculpture to their presentation exhibition. And you'll be happy to know that in July there was annual assembly of International Institute of Welding. Of course, this year it was online. So one of our sculpture, photograph of one of our sculpture was displayed there. So it is your hobby, as Mr. Das told. So I'll just tell everybody, all the students, please, what Mrs. Vadeka was told, please do the activities, and always you will find the Indian Institute of Welding Kolkata branch or the head office to help you. So that's all. Thank you.
Thank you so much, sir, for such encouraging words. And it's so touching that you remember the names of our students also. Thank you so much. Now I would like to introduce the chief guest of this event, Sri Sanjeev Kumar Raut, our beloved president, CV Raman Global University. Sri Sanjeev Kumar Raut completed his professional graduation in electrical engineering from Institute of Engineers, India. And he has done his postgraduate diploma in management from Xavier Institute of Management, Bhubaneswar, Odisha. His sincere efforts to build up a group of educational institutions with a difference has helped to carve out a niche for himself as a visionary and reformist educationist, contributing largely towards socio-educational growth and development with unique pedagogy and leadership role. C.V. Raman College of Engineering, CVRCE, the flagship institution of C.V. Raman Group of Institution Bouquet and the pride of Odisha, has of late become an iconic institution by winning the first ever gold medal for India in water technology at World Skill Kazan, Russia. It has also become an undisputed leader in the future of skills by offering quality education and training in technical skills. This year on February 20th, CVRC has elevated to the status of university, and since then, it has been renamed as C.V. Raman Global University, Odisha. So now I would request our chief guest, Sri Sanjeev Kumar Rao, to kindly address the gathering. Sir, please.
Thank you, Prasid. Good afternoon, all of you. All the dignitaries present in this installation function of the student chapter, and our respected Vice Chancellor and all my dear students. It is really a great, day for me because setting up the Welding Center of Excellence and then getting involved in all sorts of welding competitions, starting from women's welding competition India, and then to the world skill, and again setting up the student chapter. It is a long journey for me, because the whole idea of setting up this welding center of excellence started when I met two of my students. Those were traveling from Mumbai to Bhubaneswar in flight, and during the interaction, they said that after completing the mechanical, they took training in Pune in welding engineering, and they are placed. And they, advised me just to set up a center of excellence so that many of our mechanical students can get the opportunity to take welding as a career. Being an electrical engineer, I know that time I don't have much of idea about the welding. So I really again thank Mr. Nanda to help me and to educate me, taking me around the globe and to the the Trichy for the welding institute there. And again, thanks to Mr. Honavar and all the dignitaries, those who came to my campus and delivered talks to my students about welding engineering and welding engineering as a career. Because when the word welding you listen, the general perception of the people, it goes to the only welding they see in the roadside, the spark they see, and beyond that, people, many people, they might not be knowing about it. It is a vast multidisciplinary subject, like many of the speakers they spoke about. Even the students from the computer science, engineering and all, when the IoT has come in, when the industry 4.0 has come in, when robotic welding has come in. So there is the ample opportunity. And as today we are a little late, I will minimize, my speech. I like to say, with the help of the student chapter, the first thing is I like to take forward the activity of the startups, how to encourage students, our students or the students across the state to become an entrepreneur. With the slogan of Atmanirbhar Bharat, the opportunity is knocking out our door. And we have taken a decision that we'll be establishing a completely world-class manufacturing setup in the welding in our campus, and where we'll install all the equipment, not of lab scale, for manufacturing scale, starting from additive manufacturing to your robotic welding, so that students, those who want to start a startup, they can utilize those centers to manufacture their products and go to the market with the help of the network of our auto incubations and the incubation center established by the DST, and they can become an entrepreneur. Because we see a lot of opportunity today in this sector because of the new vision of our Prime Minister to make the Atmanirbhar Bharat. And the second step, and I also like to, thank Mr. Das, who spoke about the entrepreneur course in the welding, because that is very, very essential. And that should be one of the main objective of all of us, to promote that and to encourage these young people to take this opportunity, because this is an opportunity of era, which was earlier was not available to all of us. And second thing, we like to really encourage the participation of women students in the welding. And for that we are organizing a lot of competitions. The Welding League is one of the example, where engineering graduates, students from across the country, they come and they compete. And we hope for the next time the vaccine should be available, so we should able to conduct that competition again, and encourage these women students to be part of the manufacturing sector, because India is a growing economy, and with such a large population and with such a huge economy, when you look at, you see very few percentage of women, they really participate in the manufacturing sector. When you always compare with China, you look, 70% of their workforce are women in the manufacturing sectors. In India, it is hardly 14 to 15%, and mostly it goes to the IT and tailoring and this garment sector. Manufacturing, it must be very, very negligible. So it should be an important responsibility for all of us, including the chapter, that we should encourage the women students to be a part of this, welding engineering. And with this wonderful presentation by all these professors, those who are showcasing the opportunity in the career with the new technology coming in IoT and Industry 4.0 and all these things. And it should be promoted, and this type of talks should be encouraged, should be organized virtually, because with Zoom, these are opportunities we should capitalize to really give an eye-opening for the students, that how welding can take them, give them a very better and promising career. And third step, we are very, very serious that we should participate in world skill in welding. And in fact, we have already started preparing our students for the robotic welding, but unfortunately, this skill was not included in the World Skill Shanghai this time, but this is going to be included in the France. So we are all ready to prepare ourselves to get an opportunity to compete and represent our country in the world skill in the field of welding. Because when I started the concept of collaborating skills into our regular undergraduate program, there were a lot of critics. The engineering was perceived as a program for the managers. They see very less importance of skill to be included in that, because it is perceived the skill need to be for the down the line people, for the technicians. It's not for the engineers. But the most important thing is, if the engineer doesn't understand the skill, then he cannot be a good engineer. He cannot be a good manager. To become a good manager, we should know the job. You can only know the job when you do hands-on. And today, with the national new education policy, the government, they have given a lot of emphasis incorporating collaborating skills into the higher education. And this particular thing we are doing since last 15 years. And we have established so many centers of excellence in collaborating with the industry. We have given opportunities to students to take electives in different skills, starting from the welding to air conditioning to, you can think about any such area where, we have ventured into it. And in future also, all the emerging skills, we are also going to adapt. And, we want to create a complete environment of an engineering education, higher technical education, where the best of the skills with the standard of the world skill can be available for the students to learn and to build their career. Because if you today give them an opportunity, then the new challenges which are coming with the technology in front of all the industry and all the educational institution, these students will be a leader. And they will be a leader in delivering the future of skills. They will be a leader in really showcasing their skill in the industry, helping industry to grow, and they will be the example to transform. Apti and many more girls and many more of students, they have won a lot of prizes. And every time you see, my students will be in competition. I don't know whether we can win all the prizes, but I can assure you we will be a tough competitor to all the students, those who are participating in any type of competition as far as welding engineering is concerned. It may be design, it may be hands-on skill, or it may be a paper presentation. And my students will always there to compete, because we always believe that incorporating collaborating skills into the higher education can only build a complete engineer, for the future. My dear students, and all the participants and honorable guests, I really like to thank for all your time, and all the support from the IIW chapter to set up the Center of Excellence, to give us an opportunity to offer such skill certification programs. And we are very seriously looking forward to have the international tie-up for our certifications. We want our students, before they complete their graduation, they should be certified in an international platform. And when they get into the profession, they should be a very skillful engineer to really serve their country. Thank you, all of you. Thank you very much.
Thank you so much, sir, for your inspiring words. It's always that you have been trying all possible ways for capturing the opportunities, creating such pools of platform to enhance the skills of our students so that they grow in their professional career. Thank you very much, sir. Now, I would like to call Dr. Susavan Basak, who is a professor in charge of the Center of Excellence of Welding in C.V. Raman Global University, Odisha, to give away the vote of thanks. Sir, please.
Thank you, Professor. So it is a privilege to be a part of this ceremony with such renowned personalities. My sincere thanks to our keynote speaker, Professor G.L. Datta, for enlightening us with such a innovative speech. My gratitude to all the members of IIW-India, Mr. P.K. Das sir, Shantanu sir, Vadeka sir, Rituraj sir, Devashish sir, for their contribution in making this event successful, and we look forward to your active participation in this kind of event to make this chapter a lively one. Again, a big thanks to our president, Sri Sanjeev Kumar Raut sir, for being the brain behind the setup of the Welding Center of Excellence and taking it a step forward towards the path of glory by installing the student chapter, which will be immensely helpful for all the students involved in shaping up their career. My sincere thanks to our Vice Chancellor, sir, for always being there to support us in all possible ways and to guide us through all kinds of situations. So many thanks to my senior professors, my HOD, Dr. Biswas sir, and my colleagues for your sessions and all kinds of help extended from your side. My dear students, this is the beginning of a new perspective which has an enormous potential to be explored by you people, and we are there to help you achieving that in all possible ways. My thanks to Mr. Prashit Mishra, Dean of Student Welfare, for agreeing to play the role of a moderator in this event. And lastly, to the Almighty to keep the blessings on us as it always been. Thank you. Over to you, Professor.
Thank you very much, sir. And to end with, congratulations to all the stakeholders of IIW and C.V. Raman Global University, Odisha, for the installation of the student chapter successfully. and we end this session. Thank you very much and keep safe.
Thank you, sir. Thank you, all of you.
Thank you.
Thanks.
Thank you.
Thank you, sir.
Welcome.
Thank you.
Thank you, everyone.